Okay, so last lesson we simplified. We're still going to do that. Simplifying, remember, simplifying means are there any pairs, triples, 4 of a kind, 5 of a kind, 6 of a kind left inside the radical? That's what that means. We're still going to do that. And then we did some multiplication and division. We did some multiplication and a little bit of division. Today we're going to do adding and subtracting, the other two operations. Okay? So it's a little bit different. It's a little bit different than multiplying and dividing. Okay? So if I'm adding two radicals, they both have radicals, right? First step is simplify them. Simplify them. So what we did the last couple days. What I mean by simplify is, are there any pairs? For this one is pairs, right? This one is a pairs because it's a square root in there, okay? So the first one is 3. We got to look to 3. We're going to factor tree 3 and then factor tree 75. That's the first thing we do before we do anything else when we're adding and subtracting. Well, 3 is just 3 times 1. 3 is just 3 times 1, okay? So that one doesn't even have a tree. There's no branches to that tree, just 3, okay? 75, though, we can break it down. So any two numbers. What are two numbers that multiply to be 75? 15 and 5. Remember, it could be any two numbers. There's others, too, that work, but start anywhere. All right? Well, 5, I'm going to circle 5 because I can't break that down. Then 15 is 3 times 5. Circle 3, circle 5, because those can't be broken down. Okay, then rewrite. So my next, this is part of simplifying, right? Rewrite it. So I have 8 square root 3. 3 was a tree with no branch. It was just 3, so that's why 3 stays. 75, though, is 5 times 5 times 3. So I have 6, 5 times 5 times 3. Look for pairs. Pairs of 5s. 5's going to come out, multiply, and then that's gone. Just like we did yesterday. So you're multiplying 5, not times 8, because that's a different radical. You're only multiplying it times the radical you're working with. So 5 times 6 is 30, right? So we got 8 square root 3 plus 30, and then the only thing that's left is the 3. Okay? That's step 1. Step 1 is the one that takes you the longest, but it's this one that you've done before. Okay, that's step 1. Step 2, combine like terms. Be careful, you can only combine like terms if they have the same radicand. Radicand means radical. Do they have the same radical? This one has a radical 3. This one has a radical 3, right? They're both the same, right? Both have the same, so they are like terms. So how do we do it? We only add or subtract the coefficient. These guys, 3s, leave them alone. Leave them alone, they're done. Okay? So we're only going to add 8 plus 30. That's all we're going to do. 8 plus 30. 8 plus 30 is 38. Leave square root of 3 alone. We don't add them, we don't multiply them, we don't do that for adding and subtracting. We leave them alone. Once they're simplified, leave them alone, the only thing you add or subtract are the coefficients. Okay? All right. All right. That's an addition. Let's look at the subtraction. The bottom one is subtraction. So remember, there are numbers in front. If there's nothing written, it's actually a 1. So these are negative ones. So there are negative ones there. Simplify each radical. So we got a 72 and a 200. 72 and 200. So let's break down 72 over here. Let's break down 200 over here. So 72, what two numbers multiply to be 72? There's a few of them. What are two of them? 72. Let's start with 72 first. 72. 6 and 12, right? 8 and 9. 36 and 2. Any of those, 6 and 12. Break it down again. 3 times 2. I'm going to circle the 3, circle the 2, because those branches don't go any further, because 3 is 3 times 1, 2 is 2 times 1. 12. 4 times 3, circle of 3. 4 is 2 times 2, circle the 2's. So 72 has got 3 times 3 times 2 times 2 times 2. Now 200. 20 times 10, 100 times 2, 25 times 8. Any of those work. I'll do 200 or 20 times 10. 4 times 5, circle the 5. 2 times 2, circle the 2's. And then 10 is 5 times 2. Circle the 5, circle the 2. Rewrite. -1 minus 1. So I'm going to rewrite it. 72 is not 72 anymore. It's 3 times 3 times 2 times 2 times 2. Okay. 200 is not 200 anymore. It's 5 times 5 times 2 times 2 times 2. Okay? There's still 72. Like, what happened to 72? It's still 72. If you were to multiply all these numbers here, you'd get 72, and multiply all these numbers, you would get 200. So it's not like I changed it. it just looks different. Pairs. Look for pairs. Pair of 3s, pair of 2s. So that means they come out in front and multiply. Pair of 5s, pair of 2s. And when they do that, they disappear from the inside. Multiply. 2 times 3 times -1. 2 times 3 times -1. -6. The only thing that's left over is just a 1, or sorry, a 2. Two times 5 times 1 is -10, -10. The only thing that's left over is a 2. That's step 1. Step 2, combine like terms, but they have to have the same radical part. They have to have the same radicand. Right? So let's look. This one's got a square root of 2. This one's got a square root of 2. A student last period asked, what if this was different? What if this was 3 in there? Then you couldn't do anything. That would be your answer. If that was a 3, that would be your answer, because they're not like terms, right? Because it's a 2, it is like terms. Leave the square root of 2 alone. Your answer is going to have a square root of 2. We're not adding them, we're not subtracting them. Once they're simplified, leave them alone. What we are adding or subtracting is the coefficients. So you're going to add these two guys together, or subtract them, however you want to think of it. -6 minus 10, or -6 plus -10 is -16. Not bad, just different, okay? It's different than multiplying and dividing, okay? So it's not hard, but it's different. So just don't get them confused. That's why we're going to practice later, okay? All right, so let's look at the back. So the back is 2 things. You probably heard of, if you don't remember, I think you start talking about rational and irrational in junior high, and then in Math 1. I don't know if you do a lot of Math 2, but we come back to it. Rational numbers. There's 2 groups of numbers, right? Any number I can put in my calculator, there's 2 groups. Rationals and irrationals. Every number fits into one of those 2 categories. What are rational numbers? Rational numbers are numbers that can be written as a fraction. If I can write it as a fraction, it's rational. What if it's a decimal? Its decimal has to be repeating the same number every time, or the same numbers every time. or their decimals have to finish, right? They finish. $2.50, right? That's a terminating decimal. It finishes. It doesn't go 2.5682, whatever. Pi. Pi is not pi is a non-terminating decimal. Irrational, you can't write it as a fraction. Can't write it as a fraction. Why can't we write it as a fraction? Because the decimal doesn't repeat. It's like a bunch of random numbers that don't repeat. Or it doesn't end, and it doesn't end. Okay? So what we're going to do is we're going to go through these examples and figure out which one's which. Which one's which. They all fit into one category or the other. So that's why you got your calculator. You got your calculator because your calculator will help you out here. 2a. Is it rational or irrational? This one's actually easier than you think. Is it rational or irrational? It is rational. Why is it rational? What's the giveaway? Because it's a fraction, right? It can be divided, right? If you divide it, you'd get -5, right? And -5 can be written as a fraction, right? Anything that's a fraction, rational. This one's rational. So this guy is rational because it's a fraction. Okay. Let's look at B, right next door. Square root of 36. What is the square root of 36? 6, right? Can 6 be written as a fraction? Yeah, 6/1. We usually don't write it like that, but it can be. So this one is rational because it's a fraction. Okay? 2c. It's rational, right? I had a student say, oh, I divided it in my calculator, and it didn't stop. It went 3, 3, 3, 3, 3. But that's a repeating decimal, right? If you were to put this in your calculator, you would get this. It's okay. It's a repeating decimal. And hey, it's a fraction too. They put it to you as a fraction, right? So it's okay. It's rational. It fits the rational. It fits the rational. If it's a fraction, always rational. The square root of 144. The square root of 144. Use your calculator. What is the square root of 144? Yeah, it's a decimal, right? 11 point something, 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 right? It's not repeating anything. That decimal is not repeating. It doesn't finish. Just because your calculator finished, like sometimes you think, oh, the calculator's done. Yeah, the calculator sometimes says, I can't write it, type anymore because that's all I'm programmed to do. So if you said the square root of 140, 11.8321597, none of those numbers repeat. And it doesn't finish at 7. It actually keeps going, but the calculator is only programmed to go so far. Okay, if you had a calculator that could go further, it would keep going. So this one is irrational because it has a non-repeating decimal. Decimals are okay. Just because it's a decimal doesn't mean it's going to be irrational. Like the last one, 2c was rational, but it has to repeat. Has to repeat. Okay? All right, so let's go to 2e. If you're not sure, use your calculator. What do you get when you multiply them? 10, right? This guy, the square root of 4 is 2. This guy, the square root of 25 is 5. So you actually just get 10/1. That is rational because it's a fraction. Okay. F. F's kind of tricky. It's a decimal. Does it repeat? No, yeah. There's a pattern, but it doesn't repeat. What's the difference between a pattern and a repeat? Well, I'm going to underline the pattern. Right? That's the pattern. But is it the same number repeating every time? No, it's different, right? If it was 0.82, 0.82, 0.82, 82, 82, 82, 82, that's repeating. This one's not repeating. It's close, but it's not repeating. They're different numbers every time. 82, 822, 8222, 82222, right? So this one is irrational. Non-repeating. It's non-repeating decimal. Okay. All right. Okay, so number 3. This is a question that was on last year for my chapter test. For this chapter test, when we took the test, this was a question on there. There's going to be something similar to this, but not exactly. So I wanted to put this on there so you had it in your notes so you can use it on the next test. So one of them, when you add them, it's going to be irrational. 3 of them are rational. One of them is irrational. Which one do you think? You can use your calculator. Yeah, why C? You're right. Yeah, right? C is the dead giveaway. Why is C the dead giveaway? This guy right there. Yeah, this guy right there. 16, 1. Those are all perfect square numbers. So really this is 4 plus 1, right? This is really 4 plus 1, which is 5. That's rational. 25 plus 4. Square root of 25 is 5 plus 2, which is 7, right? And then 7 times 7 is 49, and 3 times 3 is 9. So 7 plus 3 is 10, right? This guy is 6 plus the square root of 7. The square root of 7 is a non-repeating decimal. If it's one of these numbers, square root, you're okay. But any other number, that's the dead giveaway. All of those will always be or irrational. Okay? All right. So look at the next one. Which one has one of those? Which one has one of those that we just talked about? 1, 2, 3, or 4? Well, let's go through it. 1, fraction times a fraction, right? What's a fraction times a fraction going to equal? What type of number? What type of number is if I add a fraction plus a fraction, what is it always going to equal? Or a fraction, right? If I add 2 fractions, they'll always be equal to another fraction, right? And isn't a fraction always going to be rational? Right? So I don't care what the answer is. I just know if I'm adding 2 fractions, it's always going to be another fraction. And that's rational. This one you can use your calculator, or you can use what we did yesterday, right? How do I multiply radicals? Outside times outside, inside times inside. So inside would be the square root of 25. That's just 5, right? That's rational, because I can write 5 as a fraction. Roman numeral number 2, 1/2 plus the square root of 2. We have a fraction. Is this a rational number? Is the square root of 2 a rational number? No, it's not on my list. It's not on my list. That's irrational. So that one's going to give you an irrational number. If you don't believe me, ask your calculator. It'll give you irrational. Roman numeral number 4, 3 times the square root of 49. Is 49 on my list? Yes. So really it's just 3 times 7, which is 21, rational. So the only one that's irrational is number 2, Roman numeral number 2. Okay? There's going to be a question like that on the test. Whenever we take the test, there will always be a question. Which one is rational? Which one is irrational? Okay? Which answer? You can use your calculator. You can always ask your calculator too if you need help. All right, last two. Last two, then we're done. Okay. All right. Find the sum. What does sum mean? When you see the word sum in math, what does that mean? Addition, right? It means the answer when you're adding. You're going to add some things. Product is multiplication, difference is subtraction, quotient is division. So we're adding things. What are we adding? We're adding these two roots. 3 root 5 plus 4 root 25. And then we're going to first actually add them. Well, this is like number 1. This is like the first problem we did. Simplify each radical. Okay. Simplify this guy, simplify this guy. So I got 5 and I got 25. 5 is not it's prime. It's only got 5 times 1. So it's a tree without any branches, just like the other one was that we did earlier. 25, though, is 5 times 5. Rewrite. 3 square root 5 plus 4, and then I have 5 times 5, right? Looking for pairs. Okay. Got one pair, nothing left over. So 3 square root 5 plus, this one is going to be 5 times 4, 20. What's left in the square root? Nothing, right? You don't need to write the square root. If nothing's left over, there's no purpose for it. Leave it like that. You don't have to. Some of you are writing like this, and you just kind of left it blank. Don't even have to do that. Just leave it like that. Okay? That's our answer. Are these like terms? No. Root 5, this one doesn't have a root 5, so I can't add anything. You're done. That's your answer. That's part 1 of your answer. Part 2 of the answer, is it rational or irrational? Is there any part of that that's going to be 20 is just 20 over 1. We're good there. But this guy here, it's going to be irrational, right? If you don't believe me, ask your calculator. Your calculator will tell you this part right here is going to be a non-terminating decimal, right? So because of that guy here, it's going to be irrational because it's a non-terminating decimal. Hopefully you can read my handwriting. Non-terminating decimal. Ask your calculator. Yep, that one's not there. The only square roots that are rational are these guys right here. If it's not there, it's going to be irrational. Okay? Okay, so number 6, product. Multiplication, right? You did one like this in your notes from the last time, so I want you to do that one on your own. I want you to do number 6 on your own. If you don't remember, use your practice from yesterday. Use your notes from Tuesday. If you're still not sure, I'll be walking around, I can help. Okay? Multiply, and then tell me, is your answer rational or irrational, and why? So remember, the rules for multiplication are a little bit different than addition and subtraction. Real quickly, what were the rules? How do we multiply two things with square roots? What do we multiply first? Outside to outside, inside to inside. Exactly like that. So outside to outside, so that is 3 and 4. We multiply those together. Guess what? They're on the outside. Inside times inside. 5 and 25. We multiply those together, and they're on the inside, 125. That's the first step. Then we simplify the radical. Then you simplify the radical. How do we simplify? Look for pairs on this case. So 125. 25 times 5. Circle the 5. 5 times 5. Circle the 5. Circle the 5. So we get 12 and then 3 5s. Again, we're looking for pairs. Today we're just looking for pairs. It won't always be that way. Like yesterday in your practice, some of them were triples. Some of them were 4 of a kind, 5 of a kind, 6 of a kind. Today it's just pairs. We got a pair there. 5 times 12 is 60. We're left over with root 5. Here's my question. Is it rational or irrational? Is the root part on my list anywhere? No, right? The 5 isn't on my list anywhere. So because of that, it's going to be irrational. Irrational because root 5 is a non-terminating decimal. Because root 5 is a non-terminating decimal. Okay? All right. So tape's in the back. So we have some time. We got 20-something minutes. I noticed a lot of you didn't finish your practice 1. That's what I want you to do right now. If you're done with it and you just don't know how to turn it in, I can help you do that. You use the Chromebook. Okay? But if you're not done with it, that's what I want you to work on, practice 1. If you weren't here yesterday to get practice 1, grab one out of the blue bin.